Hello students, this is video number 12, part 1, chapter 3, energy. So student, first of all, what is energy? Students, in daily life, we always use the word energy. When we are active, we say that we are full of energy. And when we are down with some injuries or feel weakness or fever, then we do not have any energy. We eat food to gain energy. Now the question is, what is energy is? According to physics, energy is capacity. The capacity to do work. Capacity to do work is known as energy. So even you can collect examples from daily life. Like first of all, I can discuss one example which is given in your book, electricity bill. Every 2 months, after the 2 months, we are getting the electricity bill. Now, you might have seen that the meter reader comes and he recorded the reading by electricity meter. Earlier, this meter, in physics, it is known as kilowatt hour meter. What it is known as? Kilowatt hour meter. Earlier, it is installed inside your home only. Now, it has been shifted to the community panels. Now, the meter reader comes and recorded the reading from the kilowatt hour meter. Now, what is that? Means the electrical energy used by the electrical appliances consumed by our household circuit. Means we are using fans, we are using bulb, we are using refrigerator, we are using fluorescent tubes, we are using cooler, we are using AC. So all these appliances are using the electrical energy. And the electrical energy used by the electrical appliances of your houses are recorded in the kilowatt hour meter. So even in morning and evening we go for walks because it makes us active. Now morning and evening walks give us energy and we feel fit and active. Now the next is relation between, next topic is relation between energy and work. Energy and work. Just see the definition of energy: the capacity to do work. The capacity to do work is known as energy. Now we are just going to find out the relation between energy and work. But before that, before we find the relation between energy and work, let us see what is work is. What is work is? Like, this is a horizontal surface or plane surface. An object is placed on it and the force F is applied on it. And when the force is applied on it, the force displaces this object up to this distance. Now, from here to here, the object has been displaced. So it is represented with S. Now this is called work done. Once again, the force is applied on the object and the object is displaced in the direction of the force applied, and this is known as work. So mathematically, work is equal to force into displacement. Once again, I am just writing it: force into displacement. Force into displacement. Work is equal to force into displacement. Now, the SI unit. The SI unit. As we know that the SI unit of force is Newton, and displacement is meter. I am just writing here SI unit. So in short form it is written as N into M, Newton meter. Just mind it, students, whenever you are asked to write the unit of any physical quantity against the name of any scientist, so its first letter should be small. But when you are abbreviating it, the letter should be capital. So just mind it. Now, Newton meter, that is equal to joule. J. Even you can write it here, joule, Joule, or in small form. 1 joule is equal to 1 Newton into 1 meter. 1 Newton into 1 meter. 2 times I have written. So this is the SI unit of work. And even the SI unit of energy is also joule only. Energy and work are closely related, so unit of energy is same as that of work, means that is joule only. Now 1 joule is equal to 1 Newton into 1 meter. Now the smaller unit of energy mainly used for heat is calorie. Smaller unit of energy is calorie. Now 1 kilo calorie, that is equal to 1000 calorie, and 1 calorie is equal to 4.2 joule. Now there is another popular unit of energy, that is electron volt, and 1 electron volt, that is equal to 1.6 into 10 raised to power minus 19 joule. Once again student, this is one of the most important unit of energy, and mostly it is used in atomic physics, and that is electron volt. EV stand for electron volt, and 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joule. Now sometime you are asked the question, define 1 joule. This is the question generally it is asked, or the SI unit of energy, or the SI unit of work. So that is joule only. So how you will define 1 joule? 1 joule is the SI unit of work. So we can say that the work done, I'm just writing it in short form. The work done is said to be, said to be 1 joule when a force of 1 Newton, moves an object through a distance of 1 meter. So this is the definition of 1 joule. So this is the relation between work done and the energy. So work is done when a force makes an object to move through some distance in the direction of the force. Now there is a direct relation of work with energy. Now when we say that a person with more energy will do more work, then a person with less energy will do less work. Thus, energy of the falling body may hit the worker on his head in case he does not wear helmet. An object in motion has an amount of energy equal to the work done on it. So, next, the relation between work and energy can be well defined by the theorem work energy theorem. Work energy theorem. Now it states that this theorem, it states that change in the energy, due to motion of an object is equal to the work done on the object. Now let us try to understand this. This is one body, and this body is moving in this direction. The body is moving in this direction. Now what happens when the force is applied, external force is applied, since it is in motion and the external force is applied in the direction of the motion of this body, what will happen? Means the speed or the velocity or the motion of the body will increase in the same direction. Since the body is already in motion and the external force is applied on it in the direction of its motion. When the external force is applied on it, what will happen? Its kinetic energy or its motion will increase. That is what work energy theorem is. Like one example is given in your book. Suppose you are going to school on bicycle. You start on a bicycle and pedal it to reach your school. Thus some force is applied by you on the bicycle, so it moves and covers some distance, hence some work is done. So in other words, your energy resulted into some work. When you pedal fast, spending more energy, your bicycle runs faster with more force, thus more work is done. So let us move to the next topic, that is forms of energy. Next topic is forms of energy. Next topic is forms of energy, or in other word you can say the types of